And that's one most important concept, which is going to be the essence of solving all the examples on partial fractions, and that is called as a degree of a polynomial. Degree of a polynomial. And what is the degree of the polynomial? So degree of the polynomial is nothing but what is the greatest exponent of the unknown variable, whether it could be x, it could be y, whatever is the variable, whatever is the highest power, and there is a way to calculate the highest power. That highest power is called as the degree of the polynomial. Okay, and why they have written as monomial with greatest exponent? Because each thing you have to take as a term. Let's say this is term 1, then there is term 2, and there is term 3. So each one individually is just one term, right? And if the polynomial has got just one term, it becomes a monomial. So polynomial is nothing but a combination of a lot of monomials. So this by itself is a monomial, this by itself is another monomial, and this itself is another monomial, right? So we have to take each term. What it means is taking each term within the polynomial or taking each monomial separately before the plus or the minus sign, and whatever is the highest power for that term, that becomes the degree of the polynomial. So we'll take the degree of this, we'll take the degree of this, we'll take the degree of this. So we have got degrees of each of the terms or each of the monomials, and whatever is the highest among all of this, the highest exponent, that becomes the degree of the whole polynomial or polynomial as a whole. So let's try to understand what we are trying to do here. Let's take some examples. Okay, so now let's take, we have a polynomial, we just have the number constant. Yeah, that's possible because we saw a polynomial could be a combination of any of these things, and we just have a constant here, the one in green color over here, right? And a constant means it is as good as multiplying with an unknown variable with a 0 exponent. So what does 9 mean? 9 can also be written as 9 into an unknown variable raised to the power 0. That's also is okay. So in this case, it is just one term, just one monomial, there is no other terms. Okay, and what is the exponent or the highest exponent of that one term? X raised to 0, the exponent is 0. So the degree of this whole polynomial becomes 0. That's how you compute it. Let's take this example. It's simply as is written as x plus 4. So there are two terms. There is one term here and there is one term here. This polynomial has got two terms or two monomials. It's made up of two monomials. This one is constant, so we don't have to worry. It is as good as x to the power of 0. And so we should take the degree or the highest exponent for each term. For this term, the highest exponent is 1 in red color, and for this term it's 0. And we have to take whatever is the highest exponent for all the terms put together. So the highest is 1, which is associated with this first term. Hence the degree of this polynomial is 1. Let's take another example. Now we have got three terms here. This one term, this second term, and this third term. And the first term, the degree is 2. The second term, the degree is 1. And the third term, the degree is kind of x raised to 0, 0. So now we have got 2, 1, and 0. Three terms, and we have got 3 degrees. So what is the highest degree for the whole polynomial? The highest degree is for the first term, which is 2. And hence, the degree of this polynomial as a whole becomes 2. Same way over here. We have got term 1 and we have got term 2 here. And the highest degree is on the first term itself, which is 3. And hence, the polynomial degree as a whole is 3. And over here, if you see that it's tricky, and I'll put some more examples here. The first term has got two variables. It has got two unknowns, x and y. And there's a second term and there's a third term. So it has got 3 terms. This term 1, term 2, and term 3. Okay. And whenever you have two variables or more than one unknown and they have some exponents, the trick is you should add them because this whole thing is part of one term itself, right? So you have to add the exponents. So 2 plus 3 is the exponent of highest exponent of this whole term, which is equal to 5. And over here, the term is second term, the exponent is 4, and the third term, there is no exponent, it is just 0. So now we have got 3 terms, and the highest power is this, 2 plus 3 is equal to 5, and hence written as 5. So the trick is, if there are multiple variables within a single term, then you have to add the exponents because we need the highest exponent of the term as a whole. Then we'll find it for each of the term, and then whatever is the highest of all of them, that will be the term or that will be the degree of the polynomial, and that's what I've written here in red. Degree of a polynomial should be counted after combining, meaning after adding the exponents of all the variables in or within a term. What does that mean? This is the term, okay? This one thing, which is whatever is before or after the plus or the minus operator is one term. So this x raised to 2 into y raised to 3, this whole thing is one term. So in this case, you need to add that because we have got two variables and hence we need to add the powers to get 5. And I put some more examples to make sure that we understand this. Although I don't think there are going to be any trick questions in the exam, but it's better to know and get this concept clear. So we have taken some examples and I put some degrees here to know how should you think about that.